Hi students, here is the video lesson of chapter 4.3 in geometry since I will not be in class today. For our objectives for lesson 4.3, we're going to be looking at the inequalities among the sides and angles of a triangle, as well as looking at the exterior angle of a triangle and how that relates to the angles inside of a triangle. So our first investigation is related to the side lengths of the triangle. So here you can see I've already pre-measured these lengths, so you'll have to pause for a second and jot down these lengths. You could certainly measure them yourselves. The units don't matter in this case as long as they're all the same for each triangle. So please pause the video for a moment, write down these measurements, and then we're going to be comparing the sides. So what I'm going to do first is I'm going to be looking at the two shorter sides, simply because our inequality relates any two sides, and we want to look at the two smallest one to rule out any smaller values or larger values that might be in place of the third side. So looking at the two smaller ones, for triangle A, we have 1.5 and 1.5. So if I combine those together, 1.5 and 1.5, is clearly a total that's bigger than 2.7 because it would be 3.0. And 2.7 was the third side. If we look at triangle B and do the same situation, triangle B has side length 1.7 and 2 as its shorter sides. And if I were to combine those together, it would be greater than the third side of 2.6. Triangle C is a length of 1.9 for the shortest one, and then we have a tie for the second shortest one between the 3.8s. So I just picked one of them. Adding 1.9 and 3.8 is clearly going to be bigger than the third side of 3.8. If we look at triangle D, its shortest two sides are 2 and 2.7. So if I combine those together, 2 and 2.7 together would be 4.7, which is clearly greater than 4.2, the longest side. And finally, triangle E, we have a side lengths of 1.2 and 2.2 for the shorter two sides. And if I add those together, I would get 3.4, which is bigger than the third side of 2.5. Now the reason again why I did the smallest two numbers is because they would have the smallest sum, and we want to compare it to the other side. So the triangle inequality conjecture says the sum of the lengths of any two sides, even when it's the smallest two, is going to be bigger than the length of the third side. Oops. So again, you take the smallest two side lengths, add them together, that total will always be bigger than the third side. If it is not, the triangle would not be able to be formed because the two smaller sides would be too short to meet. It's kind of like a bridge that rises up through the middle. When that bridge comes back down together, it's flat. And it's kind of equal with maybe the river that it's over. And so that flat length means that the two maybe legs of the triangle weren't long enough to make a peak or weren't long enough to hit each other while they were pointed upwards. So in order to make a triangle, the two sides, particularly the two smaller ones, when you add those together, they have to be bigger than the third side. For this next investigation, we're looking at simply the size of the angles versus the sides of a triangle. So it says in step 1, label the largest angle L and the smallest angle S. The middle one we'll label with an M. So just observing, it appears to be that this up here would be the largest angle, looks obtuse. The one here on the bottom right looks to be the next largest or the medium-sized angle. And then on the left, it appears to be the smallest angle. Okay, step 2 says, label the largest side L, the smallest side S, and the middle size side M. So the longest side in this particular picture is clearly the bottom, so here's our L. The smallest side is easiest to see over here on the right. And then this would make the middle side length here on the left. Then step 3 says, what do you notice about the location of the largest parts, the smallest parts, and the middle-sized parts? So if I'm looking at the largest corner compared to the largest or longest side, I can see that they are totally opposite of each other. The medium angle versus the medium side, again, totally opposite or across from each other. And smallest angle to smallest side, also across from each other. So they are across from each other. And if we use that information, we can fill in the side angle inequality conjecture. It states in a triangle, if one side is longer than another side, then the angle opposite the longer side is the largest angle, or is larger. Now the wording on that can be kind of confusing. So basically, the longest side is across from the largest angle. The smallest side is across from the smallest angle. All right, let's turn our page. Now we're going to be looking at exterior angles, and these are angles that are formed when the side of a triangle is extended beyond the intersection of the two sides, or beyond the vertex. So you can see here this one side has been extended in like a ray format, creating this exterior angle. The angle on the inside of the triangle that's next to it is called the adjacent interior angle. Adjacent meaning next to, interior meaning inside. And then the other two angles, which kind of look like base angles in this picture, those are called the remote interior angles. So they are on the inside as well, they're just not next to the exterior angles. So here it says, given the triangle, find the sum of the remote interior angles. Oops, and if I look at the picture given below here, we have a 75 degree and a 36 degree. We want to add those together. And the sum of those comes out to 111 degrees. Oh, not my best handwriting. All right, now it says, use the triangle sum conjecture, find the missing adjacent interior angle measurement. Triangle sum conjecture, remember, means all three angles in the triangle add up to 180. So we're going to use it to figure out this corner here. So I'm going to take 180 total and subtract off the two angles that were given, which is the 75 and the 36. Forgive my handwriting. It's really hard to write with a mouse. And that total comes out to 69 degrees. Not your best example number, Suchi. Make mental note. Okay, so triangle sum conjecture, the missing measurement was 69 degrees. And that would go here on the interior of the triangle. And then it says, using the linear pair conjecture, find the value of the exterior angle. So remember, any two angles that are next to each other forming a straight line, those have to add up to 180. So we would take 180 again, and this time we're going to subtract off the adjacent interior angle, which is the 69. And that's going to help us find that exterior angle number. And when I subtract these, I get 111 degrees. So it says, compare the measurements to the exterior angle and complete the conjecture. So the remote interior angles, when I added those together, I got 111. That was the two angles down here that did not touch the exterior angle. And that sum, or that total, is the exact size of the exterior angle. So we didn't even have to do all of this calculation, because if we just add these two together, it automatically gives us the exterior angle measurement. We're going to fill in this conjecture, the triangle exterior angle conjecture. It says the measure of an exterior angle of a triangle is equal to, oops, let's fling this over here. the sum of the remote interior angles of a triangle. And I capitalized sum just as a reminder that you have to add the two remote interior angles together. So I've got a whole bunch of examples down here. I'd like you to try them on your own, and what you're trying to do is get the remote interior angles again to equal the exterior angle. So I'll put up a couple of the answers here talking through it, and then maybe you could try some on your own, and I'll put up those answers. So this first one, we have 120 as the exterior angle, and I have a missing remote interior angle, and then another one of 50 degrees. These do not have to be the same, but they do have to total 120 degrees. So I'm going to take this 120, and I'm going to subtract off the 50 degrees I already know. And that would leave me with 70 degrees for this missing angle. So this one is 70. Okay, you can do the same thing for this triangle off to the right. Down below, the one on the bottom right, I guess the one on the bottom here, both of them, are going in reverse. So this time I give you the remote interior angles. You just have to add them together to get the exterior angle. And this is actually the same example. 50 and 70 would make 120. So please give these two a try. Pause the video, try these two, and then you can check your answers. All right, I hope you were able to give those a try. For this top right one, we would take the exterior angle measurement of 115, and we would subtract 50 degrees. This would leave us with a total of 65 degrees for that missing angle measurement. Down at the bottom right, it's kind of the opposite. We have the remote interior angles, so we want to add those together in order to get the exterior measurement. So I'm going to do 80 plus 25. If I add those up together, we would get 105 degrees for the exterior angle measurement. All right, if you turn the page, it is just the summary portion as well as space for your homework. For avid students, make sure you fill in that summary portion. Use this as scratch paper to this side when you do your Schoology assignment. But your Schoology assignment is lesson 4.3. And I'm expecting this to be completed by Tuesday. If your assignment is not completed by Tuesday and you were present in class, we will be having a conversation about time management. So please use your time wisely today. Thanks. Have a great day, kids.